Scientists detect record-breaking ghost particle in the Mediterranean Sea. Astronomers using a giant network of sensors, still under construction at the bottom of the Mediterranean Sea, have found the highest energy cosmic ghost particle ever detected. The neutrino, as the particle is formally known, is 30 times more energetic than any of the few hundreds of previously detected neutrinos. These tiny, high-energy particles from space are often referred to as ghostly because they are extremely volatile or vaporous and can pass through any kind of matter without changing. Neutrinos, which arrive at Earth from the far reaches of the cosmos, have almost no mass. The particles travel through the most extreme environments, including stars, planets, and entire galaxies, and yet their structure remains intact. An analysis of the neutrino authored by the KM3NET collaboration, which includes more than 360 scientists from around the world, was published Wednesday in the journal Nature. Neutrinos are special cosmic messengers, bringing us unique information on the mechanisms involved in the most energetic phenomena and allowing us to explore the farthest reaches of the universe, said study co-author Rosa Caniglione, KM3NET deputy spokesperson and researcher at Italy's INFN National Institute for Nuclear Physics, in a statement. The record-breaking neutrino, named KM3-30213A, had the energy of 220 million billion electron volts. This astonishing amount makes it around 30,000 times more powerful than what the Large Hadron Collider Particle Accelerator at the European Organization for Nuclear Research (CERN) near Geneva, Switzerland, known for supercharging particles to nearly the speed of light, is capable of, according to the study authors. One way I like to think about it is that the energy of this single neutrino is equivalent to the energy released by splitting not one uranium atom, or 10 such atoms, or even a million of them, said study co-author Dr. Brad K. Gibson in an email. This one little neutrino had as much energy as the energy released by splitting 1 billion uranium atoms. A mind-boggling number when we compare the energies of our nuclear fission reactors with this one single ethereal neutrino. The particle provides some of the first evidence that such highly energetic neutrinos can be created in the universe. The team believes the neutrino came from beyond the Milky Way galaxy, but they have yet to identify its exact origin point, which raises the question of what created the neutrino and sent it flying across the cosmos in the first place, perhaps an extreme environment such as a supermassive black hole, gamma-ray burst, or supernova remnant. The groundbreaking detection is opening up a new chapter of neutrino astronomy, as well as a new observational window into the universe, said study co-author Pascal Coyle, KM3NET spokesperson and researcher at the Centre National de la Recherche Scientifique, Centre de Physique des Particules de Marseille in France. KM3NET has begun to probe a range of energy and sensitivity where detected neutrinos may originate from extreme astrophysical phenomena, Coyle said. Light in the ocean neutrinos are difficult to detect because they don't often interact with their surroundings, but they do interact with ice and water. When neutrinos interact directly with the detectors, they radiate a bluish light that can be picked up by a nearby network of digital optical sensors embedded in ice or floating in water. For example, the IceCube Neutrino Observatory at the South Pole includes a grid of more than 5,000 sensors embedded in the Antarctic ice. The detector has been operating since 2011 and has discovered hundreds of neutrinos. Scientists have been able to trace some of them back to their cosmic sources, such as a blazar or the bright core of an active galaxy. An international team conceived the idea of a network of detectors in the early 2010s known as the Cubic Kilometer Neutrino Telescope, or KM3NET, that might be able to pick up neutrinos in the deep ocean. Installation of the network began in 2015. The KM3NET made the record-breaking detection on February 13, 2023, when the particle lit up one of its two detectors. ARCA, or the astroparticle research with cosmics in the abyss, rests at a depth of 11,319 feet, 3,450 meters, while ORCA, or oscillation research with cosmics in the abyss, is at a depth of 8,038 feet, 2,450 meters at the bottom of the Mediterranean Sea. The ARCA detector, off the Sicilian coast near Capo Passero, Italy, was designed to pick up on high-energy neutrinos, while ORCA, near Toulon in southeastern France, is dedicated to the search for low-energy neutrinos. The KM3NET, which includes a grid of sensors anchored to the seabed, remains under construction. But enough detectors were in place to pick up on the high-energy neutrino, the study authors said. The ARCA detector was operating with just 10% of its planned components in place when the particle traced a nearly horizontal path through the entire telescope, setting off signals in more than one-third of the active sensors. The detector recorded over 28,000 photons of light produced by the charged particle. Mysterious, powerful origins. If the energy within the neutrino was converted for our understanding of everyday objects, it would amount to 0.0 for joules, or the energy of a ping-pong ball dropped from a height of 3.8 feet 1 meter, said study co-author Art Heijdboer, physics coordinator of KM3NET and professor at the Dutch National Institute for Subatomic Physics, or NICHEF, and University of Amsterdam in the Netherlands. That amount could power a small LED light for about 1 second, he said. So it is not a large amount of energy for everyday objects, but the fact that such an analogy with the everyday world is even possible is remarkable in itself. All this energy was contained in one single, elementary particle, Heijdboer said in an email. On a particle scale, the neutrino was considered ultra-energetic, with roughly 1 billion times 100 million times the energy of visible light photons, according to the study authors. Detecting neutrinos on Earth allows researchers to trace them back to their sources. Understanding where these particles come from could reveal more about the origin of mysterious cosmic rays, long thought to be the primary source of neutrinos when the rays strike Earth's atmosphere. The most highly energetic particles in the universe, cosmic rays, bombard Earth from space. These rays are mostly made up of protons or atomic nuclei, and they are unleashed across the universe because whatever produces them is such a powerful particle accelerator that it dwarfs the capabilities of the Large Hadron Collider. Neutrinos could inform astronomers about where cosmic rays come from and what launches them across the universe. Researchers believe something powerful unleashed the newly found neutrino, such as a gamma-ray burst or the interaction of cosmic rays with photons from the cosmic microwave background, which is leftover radiation from the Big Bang 13.8 billion years ago. During the study, the authors also identified 12 potential blazars that may be responsible for creating the neutrino. The blazars are compatible with the estimated direction the particle traveled from based on data collected by the detectors and cross-referenced data from gamma-ray, X-ray, and radio telescopes, but more research is needed. Many cosmic neutrino detections fail to show strong correlations with catalogued objects, perhaps indicating source populations that are very distant from Earth, or hinting at an as yet undiscovered type of astrophysical object, said Eric K. Blofeld, research scientist and particle astrophysicist in the Department of Physics at the University of Maryland, College Park, in an accompanying article. Blofeld was not involved in the study. Although a full understanding of the origins of this event will take time, it remains an extraordinary welcome message for KM3NET, he said.